Hi viewers, welcome to my YouTube channel. Today in this video, let us discuss about transistor. So what is a transistor? The name itself implies the transfer plus resistor is nothing but a transistor. So it is made up of an semiconductor material. It is used for an amplification, that is, it will take the small input signal, that is small input current, then it will convert it into a larger output current. That is, it will convert weak signal to strong signal. So this is called as amplification. Next, it is also used as a switch, that is switching the transistor to on and off. So here is an example. For example, if you are speaking in a mic, so you want to, so that the sound should be traveled over the longer distance. So in order to travel the sound to the longer distance, we need an amplifier, that is a transistor, which converts the weak signal into strong signal. That is the input, that it will take the smaller input and it will convert it into a larger output signal, and then it will fed into a loudspeaker. So this process is called as amplification. Next, so in order to form a diode, we require two semiconductors, that is P and N. Similarly, in order to form a transistor, we require three semiconductor material. That is, two PN diode or connector back to back to form a transistor. That is, it can be either positive connection or negative connection. In NPN, two positive, they are connected to form NPN, whereas in PNP, two negative regions, they are connected to form PNP. Here in NPN and PNP, we have two junctions. Okay, the region between N and P is called as emitter base junction, and the region between P and N are called as base collector junction. Next is the transistor symbol. It has three terminals, namely base, collector and emitter in both PNP and NPN. The difference is the symbol of the emitter, whereas in NPN, the symbol here, it is in towards out, whereas in PNP, the symbol, it is towards in. So what is an emitter? Emitter, it will emit the electrons, whereas base, it will accept the electrons from the emitter and it will transfer it to the next terminal, that is collector. The collector will accept the electron from the base. So emitter is heavily doped, base is lightly doped and collector is moderately doped. Here is a working of a transistor. So in order for a transistor to work, we need to meet two conditions, that is, base emitter should be forward biased and base collector should be reverse biased. That is, you have to connect the terminals in such a way that negative and negative should be connected and positive should be connected, so that NP will become forward biased. And similarly, for P and N to be reverse biased, they should be connected to a different polarities. That is, N should be connected to positive, P should be connected to negative, so that it will become reverse biased. So in this NPN, the majority carriers are electrons. Okay, here the majority carriers are electrons. So when these two conditions are met, that is NP is forward biased, that is emitter base is forward biased and collector base is reverse biased. When these two conditions are met, the transistor starts to work. Here this negative is connected to electrons, so they both are same carriers, so they both get repelled. So the repelled electrons and the holes in p types, so they both get attracted to each other because different charges attract to each other, and the remaining electrons in the n type, they move towards the electrons in the third region, that is n type. So here there will be electrons, that is negative, so it is connected to positive, so negative and positive, so the different charges get attracted to each other, and hence this is how the transistor works in NPN. Whereas in PNP, similarly, in order to make the transistor work, we have to connect that emitter and base to be forward biased and base and collector to be reverse biased. That is, in order to make the emitter base to be forward biased, we have to connect it to the same polarity. In order to make the base collector to be in reverse biased, we have to connect it to the different polarity. Here the majority carriers will be holes. So this positive that is connected to positive, that is holes also positive, and hence the same charges repel, and hence it got repelled and moved towards the electron. So here electrons and holes, they are opposite carriers, so they get attracted, opposite charges get attracted, and remaining holes in p-type, they move towards the hole in the third region, that is p region. So this hole, they move towards the negative. So here they are different charges, so they get attracted to each other, and this is how the transistor gets work in PNP. So when compared to PNP, NPN, that is most commonly used, because the mobility of electron in NPN is more, that is movement of electron is more. Okay, so that's why we are using NPN in most of the applications. Next, how the transistor works as a switch in NPN. Here the same way, here we are choosing NPN transistor. Here the connections are made in similar, that is base emitter should be in forward biased, and similarly base and collector should be in reverse biased. So after the connections are made, the transistor starts working. So when transistor is on, when high input is applied, the base current will be high, collector current will be high, the voltage across the resistance will also be high, but the output voltage will be low. When transistor is in off condition, base current will be low, collector current will also be low, the voltage across the resistance will also be low, but the output current will be high. When input of high is given, output will be low. Same way, when low output is given, low input is given, output will be high. Okay, so this is how the transistor acts as a switch. Similarly, here the transistor configuration, here for both NPN and PNP we have. Okay, so we have three configuration, namely common emitter, common base, common collector. So in all these regions, the common region is emitter. So the name itself implies that emitter is common, base is common, collector is common. So that region has to be grounded, that terminal has to be grounded. So in common emitter, emitter should be grounded, common base, base should be grounded, common collector, the collector should be grounded. But the only difference is in NPN, the symbol should be towards out, whereas in PNP the symbol should be towards in. Next is its type. So there are two types of transistor, namely BJT and FET, and we also have unipolar junction transistor. So in the difference between BJT and FET is, BJT is a current control device, whereas FET is a voltage control device. So BJT is broadly divided into NPN and PNP transistor, whereas FET is again divided into JFET, that is junction field effect transistor, metal oxide semiconductor field effect transistor. Then they are subdivided into N-type and P-type. In next video, we will discuss about its type in brief. Okay, so thank you for watching this video, and please do subscribe this channel and click bell icon for more updates. Thank you.